about Theorem 3 and 4. Now before I do the proof of Theorem 3, I quickly want to explain what it means. If you have two triangles, and you can prove that this side length divided by that side length equals this side length divided by that side length equals this side length divided by that side length. So the proportions of all the side lengths are the same. Then these two triangles are similar. Right, now let's quickly go through the theorem. The reason if you use this theorem is the sides are proportional. So they give us two triangles, a small one and a large one, and they also give us that the proportions are equal. Therefore, AB over BE will be the same as AC over BG will be the same as BC over EG. We must prove that angle A equals angle B, angle B equals angle E, and angle C equals angle G. Then these two triangles are similar. So, again, we do a construction. We draw line HI so that the top part on the left hand side, AH, is equal to ED, and that AI is equal to DG. So we construct it so that it looks like that. Now for the proof, they give us that AB over DE equals AC over DG. There they give us that. So we start with the first two proportions. That's given. According to the construction that we did, we use a previous theorem, and that says that AB over AH equals AC over AI. And these are the dotted ones. Okay, so this proportion is given, and these proportions is according to the construction and the previous theorem.
And for those proportions to be the second one to be correct, doesn't HI and BC need to be parallel?
Yes, we are going to conclude that they are parallel. Yeah, that's right.
Then how do you get to that statement, how do you create that statement if they're not parallel?
It's according to the construction.
Like when I said if I throw something and I tell you that it's parallel.
No. AB okay, are you with me? Right. So, because they are parallel, we constructed these two proportions, therefore those two lines are parallel. Because they are parallel, it means that those two angles are the same and these two angles are the same because they are corresponding angles. And therefore, the small triangle on top is similar to the large triangle. And now you can write your proportions. HI, the last two letters, over BC, the last two letters, will be equal to AH, the first two, over AB, the first two. But we constructed that AH equals DE. But these two side lengths are the same. And that's equal to the third one. So now we have that HI is equal to EG. And therefore we have congruency, side, side, side. And because the triangles are congruent, it means that they are also similar. Side, 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 side.
Side proves congruency.
Yeah,
That's what it is.
if they are congruent, it means that they are similar. Therefore, the two triangles are similar. Okay, so what did we prove here? We proved that if all three sides, the proportions are equal, then these two triangles are similar. Okay. Now the good part of this theorem is you don't need to know how to prove it. You only have to understand it. Yeah, that's great. Now, let me explain. Now let's explain Theorem 4.
Before you do that, how, after constructing a line, is it always, let's say, parallel?
Now you have to prove that it's parallel. It's parallel because we have proportions that are equal.
Then how do you? Because you drew the line before. You're the one that drew the line and made the mistake. Yeah, so I'm the one who drew it.
I did it perfect.
Okay, let's just carry on. You don't need to prove that. The fourth theorem says, if you have a triangle and a bigger one, and you need to prove them similar, you can also prove that this proportion is equal to that proportion, and this angle is equal to that angle. So if you can prove that these two proportions are equal with an included angle that is equal, then these two triangles are similar. Okay, that is theorem 4. There is the proof or the reasoning or the help. You don't have to know the proof, but this construction or this picture will help you to understand theorem 4. So if xy over pq is equal to xz over pr and angle x equals angle p, then the two triangles are similar. The reason for that is equal angles between proportional sides.
So does always have to be an included angle?
It has to be an included angle, yes. So today you learned two ways to prove similarity. It's when all the sides are proportional and equal, then it's similar. Or when you have two proportions and an included angle, then the triangles are similar. You don't need to know the proofs of theorem 3 or 4. Okay, we're still busy. Let's look at example 1. They say that you have a big triangle DGH and they give you side lengths of all the pieces. Now they ask you, prove that the inside triangle is similar to the big triangle. So my yellow one with my blue one. And you start with in triangle yellow and triangle blue. Right, which theorem would you use to prove those two triangles similar? Theorem 3 or 4? 3, because we have side lengths of all the sides. So, I'm going to use the little bird on top and the smile at the bottom. First, I'm going to say DE, the left wing of the bird, over DH, the left wing of the bird, equals, and then you substitute the values and you get a half. Why can I say that? Because all the side lengths are given. Then you do the right wing of the bird. EF over HG, substitute and also get a half. All the side lengths are given.
And you have to put that reason.
Yes. And you have to write it 3 times. And then you do the third one, the smile at the bottom, DF over DG, substitute and get a half, given. And because all the answers are the same, we can say that the proportions are the same. Yes, or you can work out one of them and then use it. And what can we deduct when all the proportions are the same? The triangles are similar because the sides are proportional.
Does congruent mean like they can fit on everyone to each other?
Pardon?
Does congruent mean that like the two triangles can fit exactly on each other?
Yes. Similar means you have a big brother and a small brother. They look exactly the same. Okay, then for example 2, Okay, you have to write a little bit smaller because example 2 has a lot to write. Can I carry on? In example 2, you need to add the 6 on side length NA. Is yours there? Oh, the Afrikaans ones aren't there. Now you see that you have a side length and a side length and an angle. And the same angle on the other in the other triangle with a side length and a side length. So what do you think must we prove?
Similarity.
No. No. No.
Oh, you mean the question?
No, I don't want the question. What must we prove for similarity?
The sides of the line and the included angle.
Yes. We need to prove that the proportions of these sides are the same and there's an included angle. Okay. Now we get to the question. They say solve the two triangles. What does that mean?
Get the angles and the sides that are the same.
Yes. You must get all the angles and all the side lengths that are not there. Okay, so let's start by first proving it similar. We look at this proportion and we have an included angle, and then we look at the other proportion. If we have the same answer to the proportions and the same answer to the included angles, then we have similarity. Why do I want to prove similarity first?
Then you can get the other sides by equal.
Yes, then you can get the other sides with proportions and the other angles. Okay. Julle is slim.
You can.
You can, definitely.
Ma'am, can you give something quickly? You. Oh. Yes, I'm not.
Yes, sir.
What?
Yes, sir. Hulle is lelik met jou. Okay, have we started solving the problem? No, we need to get the angles and the side lengths. So, if you use your over ka and al over an, we can work out what is your. And we can say that this is true because we have angular triangles. It's a tongue twister. Equiangular.
But you figure out which sides are proportional by how you like set it up there after seeing that they are similar.
Yeah.
I mean, which sides are like supposed to each other.
Yeah, I use that similarity. Okay, now I have all three sides of both triangles. Do I have all three angles? Not yet. can say angle A will be equal to angle O, and that's 88,2 because we have similar triangles. And angle Y will be 41 equal to angle C with interior angles of a triangle. And then you solved both triangles.
Is this the hardest you can get?
No.
True. It's just the start.
Just the start.
So if you can't do this, the rest is easy.
Hmm?
If you can't do this one, the rest.
Okay, example 3.
Ma'am, how would you, when you get a type of question like this, how would we know which angles are equal? Like, how do we know that angle A equals angle O?
Okay, you look at your similarity statement. Angle Y will be equal to angle C, and O will be equal to A, and U will be equal to E. Example 3. Here they also give you all the side lengths, and they ask you to prove the big triangle similar to the small triangle. How are we going to do that? With all three proportions, right? So you say in triangle ABC and triangle DEF, and try to keep the same order that they ask, because they already asked you it in the correct order. Oh, yeah, that's it. So to get the three proportions, you draw a little bird on top and a smile at the bottom. And then you do left wing over left wing, and right wing over right wing, and smile over smile. And you get all your answers as 3 over 2, and they're all given because they give you all the side lengths. If all the answers are the same, what can you conclude? The sides are proportional, and then you can conclude that the triangles are similar because the sides are proportional.
Do we need to write that?
Yes, we do.
Do I give a mark or do they give marks for that last mark?
Yes, yes. Or they can subtract. Notation. We had a subject meeting yesterday afternoon, and we're also going to have one tomorrow afternoon, where we get, I wouldn't say tips, but what they are looking for when they mark Euclidean. So tomorrow I will give you feedback on yesterday's one, and then on Friday I'll give you feedback on Thursday's one. Okay. Let's look at example 4. In example 4, they say ABCD is a quadrilateral and they give you two multiplication sums regarding side lengths. And then they ask you, prove that the pink triangle is similar to the green triangle. What can I do with those two multiplication sums? Yes, we can make them proportions. So you start by saying, in the pink triangle and the green triangle, and where do I start with these? You go to your triangle names and you make the bird and the smile with what you have. I have AE, so it's the left wing of the bird. I have BE, which is the right wing of that bird. I have CE, which is the left wing of the green one. I have DE, which is the right wing of the pink one. So I have a bird and a bird. And then you start with saying AE over CE equals ED over EB. AE, the left wing over the left wing, equals the right wing over the right wing. You can decide to write it alphabetically or according to your picture. Hi, Booty. So we change the multiplication to a proportion, and we can do the same with the other multiplication. Change that to a proportion. You can rub that bird out, and then you draw the new lines of the other multiplication sum. And then you'll see that the left-hand side, the right-hand side of the first proportion equals the left-hand side of the next one. Therefore, all three proportions are equal. And what can you conclude then? Similarity, because the sides are proportional. Okay, now the number B in the question, you can do under your picture if you have space there. Otherwise, you need some other paper. It's 4 lines. You're still busy? With number B, they give you that AD is a half of CD. So that's given. Now you can divide on the right hand side with CB, and then you get a proportion. Therefore, the side length AD is 1 and the side length CB is 2. But when you look back at your previous answer, you'll see that AD over CB is also equal to DE over BE. So that's where I get this from. So this proportion is also a half. But I don't want it in a proportion, I want it something to something. So you just write it like that. Your homework for tomorrow. This proportion is equal to the other two. So all of them is a half. Is that what you said? Yes, yes. Yeah.
Also the question. Why is it the half?
Because all the proportions are equal. So if this one is a half, that one is a half, and that one is a half.
I'll come up.
Homework is exercise 4 on page 27, number 1 till 4.